Geometry 11.3 Perimeter and area of similar figures. By the end of this lesson, you should be able to compare the perimeter and area of a polygon. You should also be able to use the perimeter and area of similar polygons to calculate missing measures. Everything in this lesson pertains to this one theorem regarding the areas of similar polygons. If two polygons are similar with the lengths of corresponding sides and the ratio of a to b, then the ratio of their areas is a squared to b squared. So in a previous chapter, we learned that the ratio of the sides of similar figures is going to be equal to the ratio of their perimeters. So here we have the ratio of their sides, and the area of quadrilateral 1 and quadrilateral 2, we know at least their ratio will be a squared to b squared, depending on what this a and b will be when we simplify it. Let's try a couple examples. In our first example, they tell us that hexagons A and B are both similar, and we're asked to find the ratio of the perimeters and the ratio of the areas. The ratio of the perimeters can be found by the ratio of the side lengths of these similar polygons, which is 7/21. When we simplify this, and you'll need to make sure that you're working with simplified ratios, we'll end up with 1/3, because we can divide both numerator and denominator by 7. What this means then is this is our A and our B that we're working with. So when we're asked to find the ratio of the areas of the hexagons, which we know is in the form of a squared over b squared, we can take our previous ratio to find our ratio of our areas. So the ratio of our areas will be 1 squared over 3 squared, which is 1/9. In another example, we have a park that has 2 gazebos. The floor of each gazebo has the shape of a regular hexagon. The floor of one gazebo has a perimeter of 72 feet and an area of about 374.12 square feet. The floor of the larger gazebo has a perimeter of 96 feet. Find its area. Before we can find its area, we need to make sure that these two gazebos are similar. And the key part of this problem's explanation is that they're regular hexagons. And these two gazebo floors being regular hexagons allows us to say that they're similar because all of its sides will be proportional and all of the angles will be congruent because they're regular, which means we can continue. We know that the ratio of the perimeters is a to b, and the ratio of the areas is a squared to b squared. So what we'll do is we'll use the given information saying that one gazebo has a perimeter of 72 feet and the other gazebo has a perimeter of 96 feet to find this ratio. So we can say that the ratio of the perimeters is 72 over 96, which we'll want to simplify. 72 over 96 when we simplify gives us 3/4. So this is the ratio of our perimeters, which we'll use to find the ratio of our areas. So this is our A and B that we're going to be working with. Since the ratio of the areas is a squared to b squared, we know that when simplified, this ratio will be 3 squared over 4 squared, in other words, 9/16. But this is our simplified ratio of the areas. What we need to do is use the given information about one of our actual areas and set up a proportion in order to solve for the other. So what we can say is 9/16 is equal to 374.12 over x. This x will give us the area of our larger gazebo. So here we can cross multiply and solve. 16 times 374.12 will give us about 5,985.92, and that'll be equal to 9x. And when we divide by 9, we will end up with 665.1 feet squared. So we can say that the larger gazebo has an area of 665.1 feet squared. Now, thinking about this in the last section, you could figure out the perimeter and use the side length in order to calculate the area of those polygons. However, this ends up being a little bit less work than what we were dealing with at the last section. So it's just another way that you can calculate the area of a similar polygon. We're all done, so it's time for our joke. What is the cleanest part of a stadium? The bleachers.